All right, so this is part 2 of the videos, okay? So make sure you already watched the one about linear functions. This is the one about inequalities, all right? So what's an inequality? An inequality is a sideways triangle thing. It means less than, greater than, less than or equal to, or greater than equal to. The one at the top means less than. So how are inequalities different from linear functions? There's an inequality sign instead of an equal sign. So in a linear function, x equals y. In an inequality, x is less than y. And also, linear functions have a definite answer. Where inequalities do not have a definite answer, only a range that the number could be. Let's understand that. Let's say m is less than 3. That means that m can equal anything less than 3. Negative 2, negative 1, negative 10. Anything less than the number 3. But if it's less than or equal to 3, that means m could equal 3 or anything less than 3. So 3, 2, 1, negative 100, okay? If h is greater than 6, that means that h equals anything more than 6. 7, 8, 9, 10, 12, 100. If h is greater than or equal to 6, that means that h could equal 6 or anything more than 6. Inequalities do not have a clear answer. It just tells you what the variable could be. So, for example, if y is less than 6, the variable is any number less than 6. So, now let's look at solving inequalities. Our first example is 5 plus a over 6 is less than negative 7. So, 5 plus a over 6 is less than negative 7. So, what's the first thing? We have to isolate a. What are the two things stopping a from being by itself? The 6 and the 5. So, let's do the opposite. Let's get rid of that 5. What's the opposite of 5? Negative 5. So we do negative 5 here, which crosses off, and then negative 5 here. Negative 7 minus 5 is negative 12. So we're left with a over 6 is less than negative 12. Okay, so now what's stopping a from being by itself? The divided by 6. What's the opposite of divided by 6? Times 6. So we're going to do times 6 here, which crosses out, and times 6 here. Negative 12 times 6 is negative 72. So a is less than negative 72. So how do we graph that? We look on here, we find negative 72. Now it's just less than, meaning we do an open circle. And then we point it in the way of the inequality. So a could equal negative 73, negative 74, negative 75. It cannot equal negative 72 because it's less than negative 72. All right, so example 2. 30 is less than or equal to 6 plus 4c. So this one I want you to do on your own, but I gave you hints. First, isolate c by subtracting 6 from each side. Isolate c by dividing 4 from each side. And then make the c come first. And then you got to graph it. Now this one is less than or equal to. So when you graph it, it's going to be a closed circle. Okay. Example number 3. It is 2 minus 5b is greater than 32. So let's write that down. Two minus 5b is greater than or equal to 32. So what are the two things stopping b from being by itself? The 2 and the negative 5. Let's deal with that 2 first. Opposite of 2 is minus 2. 2 minus 2 is 0, you cross it out. If we do minus 2 there, we have to do minus 2 over here. 32 minus 2 is 30. So we're left with negative 5b is greater than or equal to 30. Now, what's stopping b from being by itself? The 5. We're not going to worry about the negative just yet. So, this is 5 times b. What's the opposite? Times, divide. It's going to divide by 5 here. 5 divided by 5 is 1, so it crosses out. Divide by 5 here. 30 divided by 5 is 6. So now we're left with negative b is greater than or equal to 6. Now, we cannot have a negative on this variable. So how do we get rid of it? We can just pop that negative over to the other side. However, if we do this, that inequality has to turn around, become the opposite. Okay? So it's with b is less than or equal to negative 6. So if we want to graph it, we're going to do a closed circle on negative 6. Then the inequality is pointing that way, so we're going to do it that way. And we know that b could equal negative 6 or negative 7, 8, negative 7, negative 8, negative 9, negative 10, any number smaller. Then it could equal negative 6 or anything smaller than that. All right, so for example 4, I want you to do this one yourself. 43 is greater than negative 5h plus 3. Keep in mind that that's a negative variable and h is on the second half of the equation. You need to make it first before you graph. All right, so I want you to pause the video and try that one out. All right, so those were basic inequalities. Let's talk about linear inequalities that look like linear equations. So they can look like y is less than or equal to 2x minus 4. Looks a lot like a linear equation, but the graphs look a lot different. So let's say we graphed it. We'd graph it by doing a chart and getting all the possible values of y with x, but here's where it gets trickier. It's a range, so we don't have a definite answer. So all these shaded areas are all the things that y could equal, okay? It could equal anything on this pink line or anything that's shaded pink. So same thing with next one. Y is greater than or equal to 3x plus 1. So y could equal anything on this pink line or anything in this shaded area. Now with both of these, keep in mind that that is a solid line. But with this one, y is less than x plus 7. Not less than or equal to, just less than. We use a dashed line because y cannot equal anything on that line. It can equal anything that's pink, but not anything on that line. Same thing where y is greater than 5x plus 7. We use a dashed line. Y cannot equal anything on that line, but it can equal anything in this pink area. Nothing in this white area, just the pink. All right, now I want you to answer some questions. So, first off, match the linear function to the chart. So for example, the first one is y equals 6x plus 3. Which chart does that match? A, B, C, or D? Now, here's a hint. Look at the y-intercept and look at the slope to help you figure that out. Here's the second problem. Should this graph have a solid line or a dashed line? So look at these inequalities. Is it less than and greater than, or less than and equal to, and greater than or equal to? Tell me if it needs to have a solid line or a dashed line. Use these notes to help you if you're not sure. And then finally, match the inequalities to the number line graph. So for example, J is greater than 9. Is that this graph, this graph, this graph, or this graph? Keep in mind about whether it has a closed or open circle and which way the inequality is pointing. All right? So again, I'm Miss Nolan. If you have any questions, here's my email, snolan@fallriverschools.org, and I'll be more than happy to help you. All right, everyone, have a good day.